Hello everyone, welcome to session number 25 of Java programming. In today's lecture, we will learn how to establish database connectivity using JDBC, which stands for Java Database Connectivity. How does a Java application such as food delivery service communicate with the database to store user details, confirm bookings, and update transactions instantly? The answer lies in JDBC, which acts as a bridge between Java applications and databases. By the end of this session, you will understand what JDBC is, how it works, and how Java applications interact with databases using JDBC. When an admin adds train details or a customer books a ticket, database operations such as insert, update, and select are performed. JDBC enables Java applications to execute these database operations efficiently. In this session, we will study the JDBC API, JDBC architecture, JDBC drivers, JDBC workflow, and different types of JDBC drivers. JDBC stands for Java Database Connectivity. It is a Java API used to connect and execute queries with a database. JDBC was introduced in 1997 with JDK 1.1 by Sun Microsystems. ODBC is not suitable for Java because it is platform dependent, requires native drivers, and causes memory issues. JDBC supports Java's write once, run anywhere principle and is designed for internet-based applications. JDBC is designed specifically for Java applications, whereas ODBC is platform dependent. ODBC requires native drivers, while JDBC is safer and fully compatible with Java features. JDBC is a Java API that allows Java programs to connect to a database, send SQL queries, and retrieve or modify data. It acts as a bridge between Java applications and databases such as MySQL, Oracle, SQL Server, and PostgreSQL. An API is a set of rules that allows two software applications to communicate, just like a messenger carrying requests and responses. JDBC has four main components. First, the JDBC API, which provides packages such as java.sql and javax.sql. Second, the JDBC driver manager, which loads the appropriate database driver. Third, the JDBC test suite used for testing JDBC operations. Fourth, the JDBC ODBC bridge, which converts JDBC calls to ODBC calls. JDBC architecture explains how a Java application communicates with a database. It consists of the Java application layer, JDBC API, driver manager, and JDBC drivers. JDBC supports both two-tier and three-tier architectures. The Java application contains business logic and SQL statements. The JDBC API provides interfaces such as driver, connection, statement, and result set. The driver manager manages database specific drivers. JDBC drivers communicate directly with the database. This diagram shows how a Java application communicates with the database using JDBC drivers through the driver manager. There are two types of JDBC architecture, two-tier and three-tier. In the two-tier model, the Java application communicates directly with the database. In the three-tier model, communication happens through a middle tier service. In the two-tier architecture, the Java application acts as a client and the database acts as a server. The JDBC driver enables direct communication between the application and the database. In the three-tier architecture, the client sends requests to a middle tier, which then communicates with the database. This model improves scalability, security, and performance. JDBC drivers are client-side adapters that convert Java requests into database-specific protocols. There are four types of JDBC drivers: Type 1, Type 2, Type 3, and Type 4. The Type 1 driver uses ODBC to communicate with the database. It is platform-dependent, slow, and has been removed from Java 8. The Type 2 driver uses native database client libraries. It is faster than Type 1 but is not platform independent. The Type 3 driver uses middleware to communicate with the database. It is platform independent and suitable for web applications. The Type 4 driver is a pure Java driver. It directly converts JDBC calls into database specific protocols. It is the fastest and most widely used JDBC driver. Important JDBC interfaces include driver, connection statement, prepared statement, and result set. Important classes include driver manager, blob, globe, types, and date. It is important to close the result set statement and connection to release database resources and avoid memory leaks. The JDBC workflow consists of 6 steps: load the driver, establish a connection, create a statement, execute SQL queries, process the result set, and close the connection. A JDBC driver is a software component that enables communication between a Java application and a database. Without a JDBC driver, Java cannot interact with databases. There are 4 types of JDBC drivers. Type 1 is the JDBC ODBC bridge. Type 2 is the native API driver. Type 3 is the network protocol driver. And type 4 is the thin driver. The purpose of the JDBC ODBC bridge driver is to allow Java applications to connect to databases that support only ODBC drivers by translating JDBC calls into ODBC function calls. The purpose of the native API driver, that is type 2 JDBC driver, is to allow Java applications to communicate with the database using the database native client libraries for faster and more efficient access than the JDBC ODBC bridge. The purpose of the network protocol driver, type 3 JDBC driver, is to enable Java applications to communicate with the databases through a middleware server that translates JDBC calls into database specific protocols. The purpose of the thin pure Java driver, type 4 JDBC driver, is to allow Java applications to communicate directly with the database using a fully Java-based driver without relying on native libraries or middleware. Type 1 is slow and platform dependent. Type 2 uses native libraries. Type 3 uses middleware. Type 4 is pure Java and offers the best performance. Now we'll be solving a case-based scenario problem related to this lecture. So the problem is a university management system uses JDBC to manage student records stored in a relational database. We need to answer these 3 subparts. Part A is asking to design a JDBC-based solution illustrating the complete JDBC architecture. B part, evaluate different JDBC driver types and recommend the most suitable one. And the question number C subpart is critically analyze the challenges involved in JDBC based database connectivity. So as usual, we'll be using the IntelliJ IDEA integrated development environment. However, because we have to write our JDBC program, Java program, as well as the MySQL queries, we have to use the MySQL database. So we will be making use of the MySQL workbench to write the SQL queries on the workbench using the workbench interface. So first of all, we have to understand this problem, that is university management system. So we have to propose in A part, we have to propose JDBC based solution illustrating complete JDBC architecture. So what is the problem context? A university management system needs to store student records, retrieve student details, update marks, attendance, and profiles, use a relational database that is MySQL. JDBC acts as the bridge between the Java application and the database. So JDBC architecture, in JDBC architecture, following layers are involved: Java application layer, JDBC API layer, driver manager layer, JDBC driver layer, and the database itself. So step one is to install the requisite software. We have already installed the IntelliJ IDEA IDE, also installed the Java development kit. Third software we require is MySQL Community Server. You can easily go to Google Chrome browser, and there you need to type MySQL Community Server, and then you can follow this step-by-step procedure to install this MySQL Community Server. Thereafter, you have to install the Workbench also, where we'll be using the executing the SQL queries. One more component you need to install, that is the MySQL JDBC driver, that is MySQL connector J for the MySQL database. Yeah. Now we need to open the MySQL workbench, and we are writing these queries. First of all, we are creating the database named University DB, and then we are using that database because we need to create a table named student into that database. And there are 3 fields or columns in this student table: student ID, student name, and department. The data type of student ID is integer. It is a primary key. That is, student ID is always unique, and value cannot be null. Student name can contain number of characters up to maximum 50 character, and its value cannot be null because we have specified the constraint not null. Department also, data type is varchar, variable number of characters can contain. The name of the department can contain variable number of characters, at most 30 characters, and the value of the department can also not be null because we have used the constraint not null. And then we have inserted records into this student table. We have inserted values. So we have inserted ID value as 102 and the student name Neha and ECE as the department. Clear? So as soon as we press this workbench button, this yellow button where I am hovering my mouse, all the queries will get executed successfully. As you can see, green tick here, all the queries has been executed successfully. Now we'll be writing a JDBC or Java program into the IntelliJ IDE. Uh, uh, as I've said, we need to download MySQL JDBC driver, that is MySQL database connector J. So let me tell you how to go to the Google Chrome browser. We have to write the MySQL database connector J. So you have to type this here, and the first result you have to click, that is MySQL download connector J. We have to click on this, and this window will be opened. We'll be using the previous version to in order to maintain the compatibility, though that's why we are using this version 8.4.0. And in the operating system, you have to select platform independent, and you can see here two files, tar and zip file. Tar is for Linux based system, so we have to download this zip file. We have to download this zip file by clicking on this download button. It will you will be able to download. You have to download this zip file at any place or any location within your computer system, and then you have to extract this zip file. And when you open this folder, that is MySQL data, MySQL connector J 8.4.0. After extracting it, you will find a jar .jar file into this folder. Clear? So we have to give the path of that jar file into our IntelliJ IDE. IntelliJ IDEA Integrated Development Environment. As you can see here, uh, we have to go first to the first of all we have to create a project named University JDBC, as we are already creating our project. Clear? And then this is the code for establishing connection between Java program and database connectivity and the database MySQL. And these 4 lines we have to go to these 4 lines, and then we have to go to project structure. After clicking on project structure, you have to click on libraries, and then you have to click on plus button. As you can see, I have already given the path of jar file here. So you have to click on basically on this plus button, Java, and location where you have extracted that zip file. For example, I have done on this desktop MySQL connector J, and this is the jar file within that folder. You have to double click or open this file, and you have to apply an OK button. So already I have selected this jar file. That's why it is showing here. No need to click again apply an OK. But you first time you have to click apply an OK as well. Clear? So this is the path to the jar file. Uh, Now we are in a position to write our program, Java program, and we'll be establishing a connection between our Java program and the MySQL database. Clear? Now, first statement is import java.sql.start. This line imports all JDBC classes and interfaces such as connection, driver manager, prepared statement, and SQL exception, which are required for database connectivity. Then we are having line number 3, public class main. This is the main class. This declares the main Java class named main that contains the JDBC program. Then we are having line number 5, public static void main. This is the entry point of the Java program where execution starts. And then we are having database connection details. These are the line number 7, 8, and 9. String URL is equal to JDBC colon MySQL colon localhost colon 3306. So this 3306 is the port number. Uh, when we install the MySQL community server installation, then we specify this port number. And University DB is the name of the database we have just created in our workbench. Clear? So URL is uniform resource locator, or simply you can say it is the location of the database University DB. And when you install MySQL community server, there you specify a user named as root, and there you also specify the root password. So we have given this password, root password as disturbance $18. But you can give your own password as well when you while installing the MySQL community server. I have given this password, so I am using this password. Clear? So URLs here specifies JDBC protocol, MySQL database, localhost server, port number 3306, database name University DB. Clear? And user is the MySQL username, and password is the disturbance $18. Password is the MySQL password. Then we move to the try block, line number 11. All JDBC operations are placed inside the try block to handle possible runtime exceptions. So now we are going to establish a database connection. As you can see, line number 16. Connection is the built-in class and con is the object of the connection class equal to driver manager dot get connection. Now we pass these three parameters here: URL, name of the user, and the password. So this statement, line number 16, connection con is equal to driver manager dot get connection, establishes a connection between the Java application and the MySQL database. A driver manager selects the appropriate JDBC driver, and then it returns a connection object. Then we are going to create a prepared statement. So line number 19, you can see prepared statement ps equal to con is the connection class object dot prepare statement. Prepare statement is the built-in method, and then we write the query as a parameter to the prepare statement method. Queries insert into student values. So usually whenever you are executing some SQL query, you might have seen in data DBMS subject also, you pass some specific values, but here we are, instead of passing the specific values, you are passing the question mark. It means you are passing the values dynamically, and where these values will come, I will tell you later. So this statement, con.prepare statement, creates a pre-compiled SQL statement, uses these question mark placeholders to set dynamic values, prevents SQL injection, improves performance. Now we are going to setting values for these placeholders in line number 22, 3, 23, 24. So ps.setInt 1, 101, ps.setString 2, Amit, ps.setString 3, CSC. So these statements assign values to placeholders. Index starts from 1 and node 0. Remember that index starts from 1, node 0. Values correspond to student ID, student name, and department. So after that, we execute the SQL statement using this line number 27, ps.execute update. So the this statement executes the insert query. Execute update method is used for insert or update or delete operations, and it returns the number of rows affected. And then we have to close the resources, ps.close and con.close. So both these statement closes prepare statement and the connection. It prevents memory leaks. It releases the database resources. Then we have to print the success message. As you can see in line number 33, system.out.println, student record inserted successfully. So it displays a confirmation message even if insertion is successful. And then we are having the catch block. Catch exception e dot print stack trace. So it catches any exceptions such as SQL errors, connection failure, duplicate primary key. So it prints detailed error information for debugging. So this program demonstrates how to insert a student record into a MySQL database using JDBC by establishing a connection, executing a prepared SQL statement, and properly closing resources. So you can see the output here. If we go to the workbench, because we have in this we have executed this insert query to insert single record. So uh, if you write here, so remember this one ID is 102, student name is Neha, and the department is EC. So let me show you. So see, now when we execute this select query, select star from name of the table is student. semicolon. So only one record when we execute this select query, only one record will it will show. But ID is 102, student name Neha, department is EC. So we can see here student ID 102, student name is Neha, and department is EC. Okay, but as soon as we execute this program establish a connection between this Java program itself and this database, University DB. And as we can see here, in through this program, we have inserted one more record. One more record we have inserted. What are the values? ID is 101, student name is Amit, and department is CSC. So as soon as you execute this JDBC program, we click on this green triangle button, build process starts, and we see the success message. Student, this message. Student recorded this. Student recorded inserted successfully. It means this student record has been inserted into the data into the table student. As you can see here, ID 101 and student name Amit and department CSC. This has been inserted. So you can see just a minute. Because I have clicked on this green button again, that's why it is showing this error. Duplicate entry 1014 student.primary because we have already inserted na. So you can see in the so I wanted to show you this error, this duplicate entry error. Earlier, when we press this green button, we see the success message that is student record inserted successfully. This was the message. But when you execute again, when you execute this JDBC Java program again, then it indicate duplicate entry 1014 ID because the we have in the workbench, we have in the SQL query, the ID was mentioned as primary key, and the value of the primary cannot be null, and it should be unique. It cannot be duplicated. That's why when we press this green button again, this error comes duplicate entry for ID 101 because ID we had specified the ID as the primary key. That's why. Clear? Now you can see the result now. You can again execute this query, select star from student. Earlier, only one record was there, but through JDBC program, we have inserted one more record successfully. Student record inserted successfully. Which was the record? That is ID 101, student name Amit, and department CSC. So you can check here. So execute again this query. Earlier we were having only this one record, student name Neha. So as soon as you execute this query, now second record you can see here. So Amit, student name Amit, ID 101 and department CSC. So in this manner we can solve this case-based scenario problem. Clear? So we have successfully established a connection between our Java program, this Java program, and the MySQL database. And we have executed this insert query. After inserting this record 10 with ID 101, if you run again this program again by pressing this click button, it will show this error, duplicate entry. Otherwise, in the first attempt, it will show only this this success message that is student record inserted successfully. So when you press this green button again, then because you are again inserting this record with ID, same ID, but ID was specified as a primary key. That's why it shows duplicate entry 101. Clear? So in this manner, we can execute uh, we have successfully executed our insert query through Java program. So A part, we have given solution to the A part. Now we come to the B part. B part says evaluate different JDBC driver types and recommend the most suitable one. So as in the PPT, I have also shown you there are four types of driver: type 1, type 2, type 3, type 4. So we can evaluate again for your uh, for your convenience, I can again tell you type 1 driver is the JDBC ODBC bridge and it uses ODBC. And in Java 8, it has been removed because of its slow operation. Type 2 Java is the native API driver that uses native database libraries and it is fast but platform dependent. Type 3 driver is a network protocol driver that uses middleware, but it is however scalable but complex. And type 4 is the thin driver that is a pure Java direct database access. It is faster as well as portable. So usually we use type 4 driver. So recommended driver is the type 4 driver that is pure thin Java driver. Why the type 4 Java is the recommended driver? Because it is fully written in Java, it is platform independent, it provides best performance. Type 4 driver also leads to easy deployment. It provides easy deployment. It is also an industry standard. For example, we have used the MySQL database connector J as the driver, thin driver. So it is best suited for university management system. Now we are going to solve the C part. That is critically analyze the challenges involved in JDBC based database connectivity. What can be the challenges? So challenges can be first connection management. Creating connections is expensive. Poor handling causes performance issues. So the solution to this problem is use connection pooling always. Use frameworks and second type of challenge can be resource leaks. That is, if you forget to close result set statement and connection, the resources can be leaked. Solution is to use the try statement. As you can see in this here, when we are trying to establish a connection between Java and database, we are using this. Here we have not used this is the try block. However, there is a try statement also. Uh, I will show in the later scenarios. And the third type of challenge involved can be the SQL injection. So it occurs when using statement. How can you solve this SQL injection problem using the prepared statement? As you can see, you see here, we are using the prepared statement. So this is SQL injection is also one type of attack which we will be seeing in later part of lectures 37 or 38. To prevent the SQL injection attacks, we have to use the prepared statement as we are using in line number 90. So it avoids the dynamic SQL. And fourth challenge can be scalability issues. That is, JDBC alone is not ideal for large scale systems. Solution uh, to resolve these scalability issues can be you can use the ORM frameworks like Hibernate and JPA, that is Java Persistence API, and you can combine JDBC with middle tier services. Fifth type of challenge can be database dependency. SQL differs across the DBMS. That is, the solution is you must always use standard SQL. You need to avoid vendor specific features. Use abstraction layers. Sixth challenge can be error handling complexity. So SQL exception contains vendor specific error codes. So you can the solution to this error handling complexity can be you can use proper exception handling. You can use logging and error translation layers. Seventh type of challenge can be performance overhead. That is excessive queries affect response time. If you are writing number of queries that affect the response time. So solution to the performance overhead is you can use batch processing, you can use indexing, you can use prepared statement caching. So conclusion is JDBC provides a robust and standardized way to access relational databases. Type 4 JDBC driver is the best choice for university systems. Proper design, connection pooling, and secure coding are essential. JDBC is powerful but must be used carefully to avoid performance and security issues. Thank you for watching this lecture. In the next session, we will write and execute JDBC programs. Please like, share, and subscribe for more Java programming tutorials.